Till now, to understand the acceleration, I have explained 3-4 examples, because you may understand any one of the example in a better way so that you will understand the acceleration perfectly. That is why I have taken 2-3 examples. Okay? Right. See, even though it is online class, why I am taking 3-4 examples and I am dealing with as a regular class, okay, for understanding in a better way. Okay, sometimes if you understand the acceleration in the very first case, the second case and third case you may get bored, but some people may not understand in the first case, then they will understand in the second case. Some people will understand in the third case, because every student mindset is not same. Okay, so this is for everyone. That is why I explained 3-4 examples. One example enough to understand acceleration. Okay, but I hope you understand the situation. Okay, now we are going to do some numericals on acceleration. Now we are going to solve some numericals on acceleration. So what is acceleration formula? Acceleration A is equal to change in the velocity, final velocity minus initial velocity by time. This is the formula. So A is equal to V minus U by T. This is the formula to find acceleration. But sometimes acceleration will be given in the problem. They will ask you to calculate the time. Then what happened? Bring the time from RHS to LHS. Here time is dividing V minus U. The quantity which is dividing, if you bring from RHS to LHS, multiplies. So A into T is equal to V minus U. But we want to find the T, so that I transpose the A from LHS to RHS. Here what is A does here? A multiplies T. So the quantity which is multiplies, if you transpose from LHS to RHS, that divides. So T is equal to V minus U by A. Okay. So from this formula, AT is equal to V minus U, already we have discussed here. Right. So that formula again I am writing here. So this formula I am writing as, this is left hand side equation, this is right hand side. Is equal to left hand side is LHS, is equal to right hand side is RHS, right? So LHS is equal to RHS. So that I can write this V minus U as AT. V minus U is equal to AT. This is written as V minus U is equal to, because AT is equal to V minus U, then we can write V minus U is equal to AT. Now I want to find the final velocity. Then minus U, which is in the left side, LHS, to transpose to RHS. This minus U becomes plus U. Then AT plus U, R is equal to U plus AT. Anything is okay, because A plus B is equal to B plus C. Okay. If U is asked, sometimes initial velocity is asked. The AT, which is RHS, comes to LHS. Okay, that becomes V minus AT. U is equal to V minus AT. So there is one formula, but we are writing that formula with different terms. In terms of V, in terms of U, in terms of T, in terms of A. So most of the students are failing how to change the terms and write that particular formula in terms of V, in terms of U, in terms of T. They will learn only one formula. A is equal to V minus U by T. Okay. But in the problem, sometimes time is asked. They will substitute the values and they get some confusion and they commit the problem wrong. They commit the mistakes. If you know how to change the terms, then there is no choice of committing mistakes. That is why, as a physics student, you have to learn the formula and what are the symbols present in that. That means what are the terms, what are the expressions are present in that. And you have to change the formula from LHS to RHS, RHS to LHS, everything. You have to write that formula in terms of any quantity. If you practice such a way, automatically the solving problems become easy. Okay. Now, I'm going to do one problem. A scooter. Before I am going to solve the numericals, I want to give you some conditions. So what are the conditions we have? Okay, condition number 1. If object starts from rest, initial velocity is 0. For example, you are waiting for the bus in the bus stop. Okay, your bus came, right? After you get into the bus, some passengers get into the bus, then bus starts. Okay, until then bus is at rest, right? Bus starts from rest. So no, before starting, what is the position of the bus? Is at rest, right? Whenever it is rest, is there any velocity? Does it have? It doesn't have any velocity. So we can consider as 0. Initial velocity is 0. Next, second condition. If brakes applied, if the object comes to rest due to application of brakes, then final velocity will be 0. It has certain velocity, 20 meter per second or 70 kilometer per hour the certain velocity it is moving. But after traveling certain distance, brakes applied. Then what happened? The velocity completely becomes zero. Then what is the final velocity? Zero. When brakes applied, our object come to rest, final velocity is zero. If object moves with constant velocity, acceleration will be zero. Constant velocity. For example, here the speed is 10 meter per second. After certain time, also the speed is 10 meter per second. There is no change in velocity. When there is no change in velocity, there is no acceleration. What is acceleration refers? It refers change in velocity. The rate of change of velocity is called acceleration. If there is no change in velocity, how the acceleration will possible? So acceleration is zero when the object moves with constant velocity. So please note down these conditions first. Okay, just now we have discussed conditions. During that conditions, okay, when object starts from rest, u value 0, initial velocity is 0. When brakes applied, if the object comes to rest, final velocity will be 0. When object move with the same velocity, constant velocity, there is no change in velocity, so acceleration is 0. Remember these conditions before solving the problems. Okay, now we are going to solve one problem. A scooter starts from a rest and increases its speed to 72 km per hour after 10 seconds. Find the acceleration. Find its acceleration. So scooter starts from rest. Whenever object starts from rest, initial velocity can be taken as 0. So initial velocity u can be considered as 0 and increases its speed to 72 km per hour after 10 seconds. After 10 seconds, so what is the time given? 10 seconds. What is the time given? 10 seconds. After 10 seconds, its speed increased to 72 km per hour. What is 72 km per hour? Final velocity. So final velocity v is equal to 72 km per hour. Now, what we have to calculate? We have to calculate acceleration. To calculate the acceleration, what is the formula we have? A is equal to v minus u by t. A is equal to v minus u by t. So we have to find acceleration first. That is a question mark. Then A is equal to find acceleration, we have this formula. V minus u by t. Now substitute all the values. But very important thing you have to understand. Already we have discussed in this thing in the average speed. When we talk about average speed, when we solve the problems related to the speed and average speed, already we have discussed this. Once again I am repeating you. Here second is a SI unit, okay? But kilometer per hour, is it a SI system? SI unit of this acceleration velocity? No. It is the practical unit. It is not the SI unit. Before solving the problem, first we have to change all the quantities, units must be into one system. So most probably we solve the problems in SI system. This is SI. So we have to convert this kilometer per hour into SI. Already we have discussed how to convert kilometer per hour into meter per second. Okay, so this very well. To convert kilometer per hour into meter per second, we have to multiply that given number with 5 by 18 meter per second. This we have discussed in our previous video. 1 kilometer per hour is equal to 5 by 18 meter per second. So the 72 kilometer per hour can be written as 72 into 1 kilometer per hour. 72 into 1 kilometer per hour, 72 kilometer per hour. Now 72 into 1 kilometer per hour value how much? 5 by 18 meter per second. So this number, we have to convert this kilometer per hour into meter per second. So that should be multiplied with 5 by 18 meter per second. Now it is SI unit. 18 table, 18 ones, 18 fours. 4 5s how much? 20 meter per second. This is the final velocity. Whenever you want to substitute, will you substitute this 72 as final velocity or 20 as final velocity? 20 should be substituted. 72 should not be, because it's a practical unit. Here we have SI unit. Then it also should be converted to SI. Then only we have to solve the problem. Many of the students, they know the formula. They will substitute the values. go on doing the problem without doing conversions. They commit the mistakes. Most of the times students do this mistake. That is why before solving the problem in physics, first you have to focus on units, whether all the given quantities are in one system or not. Okay, all are in the same system. Now substitute the values. What is the v value? 20 minus what is the u value? 0 by what is the t value? 10 seconds. Now a is equal to 20 minus 0, 20 by 10. Then a is equal to 2 meter per second square. This is the SI unit of the acceleration. Okay, in this way we have to calculate acceleration. Okay, please note down this problem. Let us do another problem. A car moving at a speed of 36 kilometer per hour and increased its speed to 84 kilometers per hour, 108 kilometers per hour at a rate of 5 meter per second square. Find the time taken to change the speed. This is the problem. Okay, so car is moving at a speed. Whenever very first when we are looking at the car on the road, it is moving at this velocity. What is this? Initial velocity. So initial velocity u is equal to 36 kilometer per hour and its speed increased to 108 kilometer per hour. So this is final velocity v. Final velocity v 108 kilometers per at a rate of 5 meter per second square. Meter per second square is the unit of acceleration. So the acceleration of the car during this speed of the change is 5. So acceleration a is equal to 5 meter per second square. What do we have to calculate? We have to calculate the time taken to change the speed of the car. Okay, so time should be calculated here. What is time? Again, already we have discussed acceleration formula. A is equal to v minus u by t. When you transpose the t, at into v minus u, t is equal to v minus u by a. We can use this formula, t is equal to v minus u by a. Or directly we can use this formula also, we will get, there is no issue. Okay, however you have to change, right? Now, so t is equal to, first we will discuss a is equal to v minus u by t. But here, meter per second is a SI unit, right? What is meter per second? It's a SI unit. Kilometer per hour is not SI unit, it's a practical unit. Again, what we have to do? We have to convert this kilometer per hour into meter per second. To convert kilometer per hour into meter per second, what we must do? The given number 1 kilometer per hour is equal to 5 by 18 meter per second. So that the given number must be multiplied with 5 by 18. So this is equal to 36 into 1 kilometer per hour. This can be written this way, right? That is equal to 36 into 1 kilometer per hour is equal to how many meter per second? 5 by 18 meter per second. So 18 ones, 18 twos, 2 5s are 10 meter per second. So this is the initial velocity. So in the same way, if you multiply 108 into 5 by 18, 18 ones, 18 6. 6 5s are 30 meter per second. This is final velocity. Now A should be T should be calculated. What is the A value? 5. So substitute all the values. A value is 5. That is equal to V value. Here this is a V value 30 minus U value. This is a U value 10. 36 changes to 10. Okay. By T value. T is equal to how much? That is should be calculated here. Then 5 is equal to 30 minus 10, 20 by T. If you transpose T from RHS to LHS, so 5T is equal to 20, then T is equal to 20 by 5, then T is equal to 5 4s are 20, so 4 seconds. Okay, to change this speed, what is the time taken by the car? 4 seconds. Okay, directly using only one formula. If you remember only one formula, you go this way. Or directly, if you are able to change the formula, after writing this formula, you can write this formula. T is equal to V minus U by T. What is the V value? 30. What is the V value? 30. U value 10. 30 minus 10 by A directly. 30 minus 10, 20. 20 by 5, 4. Direct. Only within one step we get the answer. If you use this formula directly, T is equal to V minus U by A. T is equal to, what is the V value? 30, U value 10, A value 5. T is equal to 30 minus 10, 20. 20 by 5, 4 meter per second. So here no confusion. If you learn all the formulas and how to change, or if you learn only one formula, you go this. Okay, it is your option. So please note down this problem and practice. Let us discuss another problem. Let's say a train moving at a speed of 90 km per hour, which comes to rest after 10 seconds due to application of brakes. So find its acceleration. Okay, so this is the problem we have. So initially, what is the speed of the train? It is moving with 90 km per hour. So what is the initial velocity? 90 km per hour. It comes to rest due to application of brakes. Brakes applied and finally the velocity becomes 0. So final velocity is 0. Okay. How much time it takes to come to rest? It takes 10 seconds. So time is 10 seconds. We have to calculate acceleration. A is equal to question mark. Okay, A is equal to V minus U by T. This is the formula we have to calculate to find the acceleration. So what is the V value? 0 minus what is the U value? 90 by what is the T value? 10. A is equal to 0 minus 90 by 10. Okay, so 0 cancel. So A is equal to minus 9 meter per second square. So whenever acceleration you get negative, it is called deceleration or retardation. Okay, so the retardation or deceleration is equal to minus 9 meter per second square. Okay, please note down this problem. So I hope you understood what is acceleration very clearly. Okay, so in this video in detail we have discussed acceleration. For understanding acceleration, I explained 3-4 examples. Okay, and we have solved some numericals. I hope you understand this part of acceleration is very clearly. In the next video we are going to talk about uniform acceleration. Okay.